Out. I hope everyone's having fun at this conference today. I'm going to go ahead and just get started with a quick story. About when I was 17 years old, I was working for a company out here in the Bay Area, and we built the servers and installed the routers and built the networks for school districts all over the Bay Area and outside of the Bay Area. One of these school districts was in Modesto, and if you're not familiar with the Bay Area, Modesto is incredibly hot compared to this area here. And I was driving this Toyota pickup truck, and it had no air conditioner. It was hot. And by the time I get out to the school every single day, I was dripping wet, miserable, sweaty, and I just couldn't cool off. So Monday, this wonderful week, they sent me out to Modesto. On Tuesday, they sent me to Modesto. Wednesday to Modesto. Thursday, they sent me to Modesto, and I said, I'm not going back to Modesto. And so I figured out a solution, and it turned out that I probably broke the law, but what I did is I logged into a network of a school nearby in a cooler climate, and I disabled a couple printers in the administration office because I knew that the next day I would get sent out to fix those printers. So that's exactly what happened. And ironically now, 15 years later or so, I am the guy responsible for detecting these types of behavior. So a little bit about me. Yes, I have 4 kids. The interesting thing is that they are all under 5 years old. We have had an onslaught of infants in our house for the last 5 years, and I love them to death, but we got a lot of them. So I've got nearly 20 years overall experience. I've worked at a ton of companies. The highlights are Google, probably Wells Fargo for the financial stuff. And lately I work at startups. I love startups. Startups have a super singular mission. It's easy to figure out what you're doing, why you're going to work every day. And everyone is pretty smart in that when you say something needs to be more secure, they get it. They get that the company depends on keeping the infrastructure secure or keeping the software secure. And so I'm going to tell you today about 4 things. I'm going to talk to you about this idea of reflective control. I'm going to tell you how GitHub's broken and how we started fixing it with GitReview and how we think we fix it with this reflective control method. And the 4th thing is other ways that this reflective control idea can be applied to keeping your information security secure, or your infrastructure, your code, your development, all the above. So starting with the reflective control. A reflective control is both a preventative control, it's a detective control, and it's administrative control. So we're going to do a quick review over controls in case anybody here has forgotten. A preventive control is kind of like a lock on a door. It keeps you in, keeps something from going in, but you can't really get around it easily. Detective control is more like the camera against the door, where you can go and look at the feed of information after the fact and find out what happened. And an administrative would be, I'm going to assign somebody to watch the camera feed all day long. And these are different kinds of controls. A reflective control is a composite of all of these. So quick story. The other day, I was using my credit card. I bought something on the internet. I typed in the information, and it got declined. And I thought that was weird. I must have had a typo. I did it again. I did it a 3rd time because I make mistakes. So then I checked my email, because that's what you do when the internet's not working for you. And I saw an email from my credit card company asking me to approve this transaction. So I went through, I approved the transaction, it worked. That's a preventative control. It prevented me from spending money. But where it got super annoying is that all day long, every time I used that credit card, when I went to Starbucks, when I went to the gas station, I'd have to go to my email, click approve, and that would allow me to slide my card the 2nd time and complete my transaction. And the point of this is that preventative controls, which is the standard, one of the easiest controls to implement, it's also one of the most frustrating for the end users. So reflective, I think, is the best of all. And here's kind of what it boils down to. something changes, and you've got software in place to detect that that changed, and you're able to identify who the subject matter experts are. So maybe this is Cisco Firewall, and every time there's a set of changes, it gets broadcast out to somebody on the firewall team. And the second part here is that they get that change, they review it, and they acknowledge that yes or no, this was a valid change, or no, it wasn't. And then the last part of this is if they don't acknowledge, you do something about that. Maybe if it's software development, maybe you block the release from going out to production. If it's a firewall change, maybe you just send off an incident to your security team, or you open it for re-review, or you could revert the change. So we'll come back to this again. We're going to move ahead to this part of the talk. How many people in the room use GitHub for development? Awesome. How many of you do code reviews on a daily basis? How many of you think that code reviews are important for quality and then for the security of your code base? So quite a few. So we have this, we have a control in place. All changes need to be peer reviewed. It's super simple, and we think it's important. We think it's so important, we've decided to make it one of our compliance controls, and it's something that we even tell our customers about. We say everything's looked at. But we also use GitHub. So we started to look at GitHub, and as we know, as anyone who's used GitHub knows, they've got this fantastic pull request feature where you can do a code review. You can see what changed. It's colorful, it's pretty. I like it. So let's figure out how to enforce that every single bit of code gets reviewed. So we started looking at the permissions, and a GitHub repository has 3 permissions, essentially. You have no access, you have read access, and you have read-write access. But there's no, you can write only through a pull request, which is what we were looking for. Now, they also have this fork and pull model, and I don't mean to fully discount it. It works great in some places. The developers that I've talked to, including myself, I don't like doing forks. It's hard to keep the code in sync. It just doesn't solve. It's kind of like the frustrated credit card issue again. So the user experience isn't there with fork and pull. But there's another more fundamental issue with it, is to do a fork and pull, there still has to be somebody with write access to the GitHub repository. That's the person who's a maintainer, that's the person who can send code into the main branch. Well, that's either a single point of failure, or we still need to monitor that the code he's letting into the branch or the main code base is appropriate. So it didn't solve the problem for us, even if there wasn't the user experience problem. GitHub is GitHub Enterprise, and I didn't see the features that we needed there as well. So bottom line, GitHub didn't have an answer to this problem. There's third-party solutions like Garrett and a bunch of others, but I have no problem with those third parties, except that my developers know GitHub. I've got 15 of them. All of our tools are built around GitHub. And GitHub is just almost an industry standard at this point. So the bottom line is, it's kind of like saying, you all have to use OpenOffice, nobody can use Word anymore. It's almost come to the point where GitHub is the de facto standard, or at least the least barrier to entry. So what are we going to do? So we look at GitHub, and we look at Git in general, and we see that this is based on a commit. Every time something's changed, a new commit is created. And there can be a lot of commits. This repository has got 28,000 commits. I don't know about you guys, but as a security guy, I'm not going to review every single one of those. I'm not going to go and track that back to find the pull request. And here's a real problem, is that there's only 5,000 pull requests. So there's 28,000 commits, there's 5,000 pull requests. Now that number, 28,000, is counting raw commits, not merges into the main branch. So it's artificially high, but there's still a discrepancy here. And so the question is, how are we going to find the commits that didn't go through the proper code review process? Because this is frustrating, right? So we wrote some software. We wrote some software called GitReview. And GitReview, excuse me. So GitReview analyzes the Git repository. It also goes out to GitHub and it pulls down all the pull requests. And it pulls out all the comments to those pull requests. And inside of those comments, there's something pretty familiar to software development. It's an LGTM, or it looks good to me. It means that somebody else took a look at that code and decided, yeah, it looks okay. Usually there's like even an LGTM, but do this and do that. But the bottom line is somebody looked at it, said it was good. And I call that peer-reviewed at this point. So we take all the PRs, or the pull requests that have that peer review, and we take a list of all the commits, and we merge them. And what comes out of that are all the commits that didn't get reviewed. Great. We fixed it. We fixed GitHub. We've got a list of violations, and that's fantastic. Except, is it? I mean, what are we going to do with this list of violations? You know, the most obvious answer is we go and we beat people over the head, and we tell them they need to go fix it. That doesn't sit well with me. I was looking for a better solution to this. So we definitely know the software's coming in, and it's not getting peer reviewed. And the first question you might be asking is, okay, well, why not just figure out a way to block that change from coming into the main branch? And I think that's important to address, is that if we don't want to take away privileges from our development staff, because they are the people that know this the best. They know better than me when they need to bypass a peer review process. Maybe it's 12 o'clock at night. They need to add a file that wasn't included for the deployment that's due the next morning. And they can't find anyone else to review their code that day. Thank you. So we want to leave it open. We want to leave the ability to bypass this process open. But we also want to manage the violations that come through. And so this is what this reflective control idea is that we were talking about a minute ago, and how we applied it to source code reviews. So what we do is simply take every single violation that comes in, and we create a ticket to another developer, another engineer, to review that code. And it's through a ticket process, so we can track whether or not it gets done. They can put their LGTM then into that ticket, since there's not a pull request associated to it. The developer reviews the code that was already changed, and at that point, he can fire off an alert, hey, this is a huge problem, this is a huge security issue, or no, this looks fine to me. It can go out to the release. And then the actual, like the meat, the iron behind this control is that the review, all of these open violation reviews have to be closed before we'll actually push go on the release to production. And so this way, we can generally keep control over the reviews that go through GitHub without changing developer workflows, without taking the ability for them to push code in away from them. And we can still manage our risk to information security. So that's the idea of the control. There's good points to it. Developers are happy. Compliance is happy. The customer is happy because they're getting their releases on time. I've got 100% code review. Check. We're tracking the time for these out-of-band changes in our ticketing system. So what we didn't have before is any idea of how long it would take to actually do these out-of-band changes, and now we do. Probably one of the best things for the developers is adding value to their day-to-day, because they're discovering problems that they thought were fine. They thought it was a simple change. But it turns out that change had impact that they didn't know about that would have normally been caught in a regular code review. But instead it's getting caught a little bit later and repaired before it becomes a bug out in production. So now for the bad points, because there are definitely bad points to this. I just gave you one of the biggest problems, which is I'm deploying this code today, and I need to make a quick change, and I can't find anyone to do a peer review. But this has to get done. Well, this process supports that, and the developer at the end of the day can make that decision whether or not he wants to push an unreviewed change into production or not. We'll still review it, but it may be a day or two after it's been running in production for a little while, so there's some risk there. Another problem is, this is probably the biggest problem I've seen so far with the system, is all of our secure files, like our authentication, is in a special directory. I get an alert every time there's a change to it. I review those changes, and somebody refactored the entire authentication system. They changed from one library to another library. And number one, I didn't know about it beforehand. Number two, it didn't go through the PR process. It went through this process. So that is a bad thing, because that is definitely something I would have liked to see PR before it got into the main code line. But at the same time, we caught it. We not only caught that we had to change the security software, but we were able to have a process in place to review that everybody knew about. And it went through the regular review steps, and it didn't actually get to production until it did get a full review. So to summarize kind of where we're at right now, so this idea of reflective control is a composite of existing controls used in a way to help us not put a preventative control in the front of the process, but put it somewhere back behind the process. I showed that GitHub is broken, and how we fixed it with GitReview, and how we fix a peer review entirely with reflective control. Woohoo! So that's great for code review, but I think that this reflective control idea applies more broadly to other areas of our infrastructure. And specifically, I'm thinking about this concept that infrastructure is code. We're pretty familiar now with Amazon Web Services, that we can write a script that builds us servers, builds us networks, builds us firewalls and routers. And we can check that script in a source code repository. And we can also audit what's actually built against a similar script, and we can detect changes. So I'm using the same process here to keep tabs of our security groups in Amazon Web Services. Namely, that every time a change comes through to those, we are getting alerted, and we're verifying that change actually makes sense. Another area, of course, is as we move toward more automation through Ansible, through Chef and Puppet, this just grows to, I think, a better way of auditing everything that changes on our systems. And the main difference I see is, instead of sending the changes to an audit team to review, we're sending it back to the folks who actually work on those systems every single day. Similar to a developer making source code changes. When they see a change to a library they worked on, they understand immediately why they made certain decisions and how that change impacts it. Same thing with the server guys. If they see that, yeah, I set up DNS or I set up mail for the entire system, and somebody just changed that, I know exactly what the impact of that change is going to be, or I can quickly go find out what it is, whereas an audit team is going to have to make a phone call, they're going to have to go to somebody's desk, they're going to have to go and do investigative research to understand what the impact of that change might be. Or they might not even recognize that there is an impact. And so that's where kind of this operations idea and this whole security idea can combine a little bit. I don't believe that your typical operations guy has the security mindset. Well, I don't want to say that. A lot of ops guys do. But the ops guys now have an ability to see what's changing to their systems by other people. They're no longer working in a vacuum. And so that's ultimately what I see with this reflective control. I'll summarize one more time. Reflective control is a composite of existing controls. We show the GitHub is broken. We fix GitHub with GitReview. We apply this reflective control to code reviews. And we talked a little bit about other applications of reflective controls. But that's not all. I've got one more thing. We've also open sourced GitReview. So you can go download a copy of this and you can try it out against your own repository. And also a link here in the slide to a long discussion on GitHub, about GitHub, and about how development shops use pull requests, forks, and pulls, and all that kind of good stuff. All right, so thank you very much. And I think we have time for questions.
We have plenty of time for questions.
Fantastic.
Ask away.
Yeah, so right now it is pulling out two things, or three things. It's pulling three things into a database. It's grabbing the LGTM, and it's looking for a couple other strings, like spelling out looks good to me, sounds good to me, a couple of those other common ones that we use. It's also pulling out the files per change, so what files were actually changed. And the point of that is that for us, we're managing, we know which files have a security impact, and that way we can send off an additional alert on security changes or changes to security files.
Which ticketing systems have you integrated with?
Jira. So he asked which ticketing systems have we integrated with, and right now it's Jira.
Do you have any updates on the code blocks that's been changed? Or is it like just do general review, like whatever is changed, it goes through a certain process?
Can you repeat that?
Let me move more specific. So, what if the organization does, different developers try to do functionalities, right? What if something is related to authentication and the other thing is related to the front end? Okay, those things have to be weighted, right?
Yeah, absolutely. So the question is, do you differentiate between changes and departments, I think? So like, let's say you've got one group of people that do front-end development, and another group of people that do back-end development, another group that do the authentication system development. Or is this tool able to differentiate between those different groups and then send that ticket to the correct, to that correct group or that correct list of people? It's a great question. The answer is no. It's on the to-do and the README file, but being able to pull out like an owner's file for a directory was the initial idea of how to implement that. So all code under a specific directory would go to a group of people, and then they would be selected for the peer review. Yep. Yeah, so the question was, how easy is this to deploy to an internal Git repo? And I think the answer is, it won't work out of the box for sure. So this definitely depends on the pull request model. So the ticketing, so you asked which ticketing systems do they integrate with? Well, there's two pieces, right? So there's a ticketing system that actually you assign a post review to, or an out-of-band review. And then there's the pull request, which is a change review process. So that's a diff, the online diff tool, I guess. And so since this is using pull request to understand whether or not there's a looks good to me, yeah, it probably won't work easily with an internal Git deployment. Well, yes and no. So if you have a tool for peer review, then you can integrate with that instead. So this tool that I've open sourced is absolutely GitHub specific, but it is modularized so that you can replace the pull request portion of it with whatever internal tool you're using and then make the same comparison across the two. Do you have a question?
I had actually the same question.
Oh, great. I'm curious, actually, what other tools for internal peer reviews are you guys looking at? Garrett? It's GitLab. I've heard of Stash. Any more questions? All right, guys, go get the software. Let me know what you think, and thanks for coming out.